So this is the last of those Linux videos. This one won't be very long because we don't have too much left to do. So this is input-output stream redirection, which is one of the super convenient things about writing code on Linux. And let me just kind of show you how it works. So you can redirect any output to a file. So that alone is worth a lot. So write this in a file named Cletus, and so if I don't redirect that output anywhere, it just goes to the screen. But I can use this redirection operator greater than, and I can say that I want that to be written to this file named cletus.txt. Now it doesn't go to the screen, it goes into cletus.txt, and I can see that by using the cat command, which we discussed earlier. Let me get rid of that because I don't really want that to be around. So one thing this does is maybe you're like me and you sometimes don't want to look up how to do file I/O because sometimes it's kind of tricky. You want to just use input from the command line and output to the command line, but you still want to work with files, and that's the kind of situation where redirection is perfect. So I've got this file called majortom.c. So I'll compile majortom.c, and this is the C compiler, and it produces an output called a.out. If I want to call it something else, I can call it something else with -o. So let's say maybe mtom. And now the most recently created file is mtom here, and you can see that it's executable, and you can actually run it. If you run it, then it waits for you to type some things in like, hey, are you listening? And all it does is make whatever you typed in come out yelling. So it just makes things yell, and the reason is that I use this function toUpper. It just converts every character to uppercase. And it'll keep doing this again and again until you type Control D, which is the end of file character in Linux, which is a very useful thing to know. So EOF, end of file, when you're getting input from the command line, is Control D. That makes it stop. But let's say that instead of typing things in on the command line like a doofus, I want to pipe in a bunch of stuff like this. So I can pipe it in to the majortom program, and then it takes that as the standard input. So that's, the pipe makes the standard out of this command the standard in of this command, and then it reads it all up here, and then it makes a capital and vomits it all out onto the screen. Now I've made this text file contain the lyrics to Major Tom, the song by David Bowie, and you can use that as input too by using the input redirection operator. So I'll send in majortom.txt into the program, and now this will be the standard input, and it'll make David Bowie yell those lyrics. Now you can do input redirection and output redirection at the same time. So maybe you want to save majortom.txt. And by the way, these file names are case sensitive, so I can do that. And now what is that? Let's just look at the first few lines of that. Come on. And what's wrong with that? Case conflict. Maybe what is this major Tom case conflict? I guess maybe I was wrong about the cases. It didn't work, right? It didn't let me save another file that was the same except for an uppercase. So I thought that would work, but it didn't. It's unfortunate that that happened because it made this seem more complicated than it really is. So let me just call this mt.txt. So see what's happening? The input redirector is taking input from here and writing to this file. So we're doing file I/O that's really just command line I/O, and so the code is much shorter, and it also gives you a lot of flexibility in how you use that. What else were we going to talk about? Here, the Linux topics. We've already talked about piping many times. Command substitution can be useful. Let me show you sort of how that works. So sometimes you want to replace something with, maybe I should give an example. What if I want to, well, this, yeah, anyway, when you put things, I'm using the, like the grave character or whatever it is that's underneath the tilde, and the effect that that has is it replaces like a command with its output. So I could do echo and ls, and then what it does is it echoes the output of the ls command. And so here's something that I like to use that for. It seems kind of obscure, but if you're doing digital forensics, sometimes you want to make a file that is a certain length in ASCII characters. And so you can type this Python, a little bit of Python code. So you want to print the character A, let's say any number of times, let's say 80 times. And so, and this is strange. This is strange. So the command that I want to encapsulate here is to echo that, and that'll print out the capital letter A 80 times. That's Python syntax. So I'll pipe it into the Python interpreter, and okay. So that's what I wanted. So that gives me my, and maybe I'm just on crack here, and I'm sure people will see that what I did can be greatly simplified. And I should have had a better example ready of how that command substitution can be useful. But that is one thing that you might use it for, is just to write out 80 capital A's, and if you wanted to, you could redirect that into a file. And now that contains the output, which is the redirection thing that we were talking about earlier. Shell scripting is a topic unto itself. So Bash has its own programming language. I have one little shell script in this directory, and where is it? I think it's called setup. Oh, sorry, it's in the steganography folder. And let's look at it. Setup.bash, and this top line, what that does is you always could have passed this code to the bash program and it would have compiled it, but this first line tells the thing that if this file is made executable and you execute it, then what that's shorthand for is passing all these commands to bash. And this is kind of silly. All it does is it executes the series of instructions that you could have executed on the command line, but that's frequently what bash scripts do. There's also syntax for doing repeat loops and conditionals and all the other things that you do in a normal programming language in the bash programming language. Quit, exit. And what else did I want to talk about? Shell scripting, environment variables. So we've already talked about environment variables a little bit because we talked about the path. So your system has many environment variables on it. If you want to see what they all are, you can type env. And so these are some of the environment variables on my system. You can modify these if you want. If the pwd command just vomits out the content of the environment variable pwd to the screen. Sometimes it can be useful to make one of these yourself. So let's say that I'm using this directory a lot and I get tired of typing all this stuff, then I could export here equals and then put in command substitution pwd, and now if I look at the contents of that variable that I just created, it is that string, and now I can do things like ls here star.c, and I can get all the C files in that folder, and maybe I go somewhere far away and I can still easily manipulate things that were happening in that other directory. So that's just one example of something you might do with an environment variable. Also in the bash scripts, you can use these just as regular variables. That's it. So those are all the things that I had planned to talk about, and now I have talked about them, however, successfully.